In this video, we're going to look at the vertex and equation of the axis of symmetry of a parabola. Given y equals ax² plus bx plus c, so this is the general form of the equation of a parabola. The x-coordinate of the vertex lies midway between the x-intercepts. So what this is saying is that if we let ax² plus bx plus c equals 0, now you might recognize this as a non-monic quadratic equation, then in fact the solution to this is x equals negative b on 2a plus or minus the square root of b squared minus 4ac over 2a. You would recognize this as the quadratic formula, but split up into two fractions instead of with a common denominator of 2a. So just a quick sketch of sort of a random parabola here. I guess what this is saying is that, let's say these are the two x-intercepts, okay, so there's a one there, one there. The vertex is in fact halfway between, so it's actually the midpoint, okay, of the two x-intercepts. Now you might be thinking to yourself, well, that's great if I can find the x-intercepts, but what about if I can't? Like, let's say the parabola, in fact, doesn't even intersect with the x-axis, so it could be a parabola that sort of does that. Does it still work? Well, yes, it does actually. In fact, the part of the quadratic formula that we're interested in is in fact not the plus or minus bit, so the part that comes after the negative b on 2a. It's actually this bit. That's the important bit. So in other words, provided the equation of the parabola is in this form, this general form, we don't actually care about the c. The x-coordinate of the vertex is negative b on 2a, and that's it. That doesn't give us the y-coordinate though. So in order to find the y-coordinate, we need to substitute in whatever this value is, or whatever we work it out to be. We'll look at an example shortly. We substitute that into the original equation of the parabola for x, sort of evaluate that, get a value for y, and then you've got the coordinates of the vertex. Great. Now, where does the equation of the axis of symmetry factor into this equation, I guess? The axis of symmetry passes through the vertex, in fact. So if that was the vertex there, there's your axis of symmetry. Okay, so it's a line, and it's in fact, the equation of the line is just x equals negative b on 2a, which is really convenient. So if you can work out the x-coordinate of the vertex, and that's easy enough, x equals negative b on 2a. In fact, this part here, right, so this bit here, this is the equation of the axis of symmetry. How nice. Let's have a look at an example. Okay, so using some specific values. Find the vertex and equation of the axis of symmetry of the parabola y equals 3x² plus 5x plus 7. I just randomly use some odd numbers there. If you graph this parabola, so you can use whatever graphing app you like, Desmos, if you've got a graphing calculator, that's fine. You'll find that there's the x-intercepts, in fact, don't exist. They're not real. So they're there, but we can't deal with them in our reality at this point. But there is still a vertex though. Okay, so let's find that. The first thing we do is we find the x-intercepts, or the x-coordinate of the vertex. So let's do that. Okay, x-coordinate of the vertex is in fact equal to negative b on 2a. Okay, so this is our a. Okay, so the coefficient of x squared, and this is our b here, which is the coefficient of x. Okay, so x is equal to, so negative b, so b happens to be 5, so it's negative 5, over 2a, so 2 times 3, which is equal to 6, and that's it. Okay, so that's sort of think of it as sort of part A. Now, we also need the y-coordinate of the vertex. Now, we've also answered the question of the axis of symmetry of the parabola, but we'll answer that later, properly in another part. So the y-coordinate of the vertex, okay, and we're going to use the original equation there. So y is equal to 3 outside of negative 5 on 6 squared. So I'm just going to substitute this for x in the original equation, plus 5 outside of negative 5 on 6 plus 7. Okay, so hopefully we can see that. I'll brighten up that screen there a little bit. That's better. All right, so let's do that. So 3 outside of -5 on 6, close bracket, squared, plus 5, open bracket, -5 on 6, close bracket, plus 7, and we get 59 on 12. Okay, so, and maybe just to have a look at it as a mixed numeral. So that's just 4 and 11 twelfths. Doesn't really matter, we can leave it as an improper fraction, that's fine. And the equation of the axis of symmetry, okay, okay. In fact, we've already expressed it in part A. We're just going to write it again. All right. It's a vertical line, and vertical lines are in the form x equals some constant or some number. X equals -5 on 6. Now, I'll invite you to graph this for yourself. Okay, so graph this equation here, 3x² plus 5x plus 7. And you can also graph x equals -5 on 6. And you can find the vertex easily enough using technology, and you can prove this for yourself. Thanks for watching.